Today, I'm going to show the simulation of power in circuit configuration for activity 1. Okay, first, let's see the circuit. This circuit contains of AC power supply, resistive load panel, single phase wattmeter, and don't forget to ground the circuit. Okay, let's see the AC supply. I set the amplitude to 141.42 volt and the frequency to 50 Hz. How does I get the amplitude? I just put it in the formula, which is VP equal to VRMS times with SERT2 and get the 141.42 volt. In the circuit, VRMS is 100 volt and the frequency is 50 Hz. Next, I put the resistive load and the single phase wattmeter. In the wattmeter, there is the current junction and the voltage junction. For the symbol of the arrow, this shows the current junction, and the polarity plus minus is for the voltage junction. For the current junction, the load must be in series. So, from the AC supply, go through the wattmeter and connect it to resistive load and go back to the AC supply. So, the arrangement in series. For the voltage junction, the load must be in parallel with the wattmeter. So, from the AC supply, and then there a junction. This show the parallel. So, the circuit the resistive in series and just plus the another junction to measure the voltage of the resistive load and finally go back to the AC supply. Okay, now let's see how does power are measured in the resistive load in this circuit. Okay, this is the following value of the resistive load. There are 8 value. This is for the single load, and for the number 5 and 6, the configuration of the load is in the series, and the number 7 and 8 is for the parallel configuration of the resistive load. Okay, now let's see how many power in the 210 of the 210 ohm. Okay, let's see. So the power of 210 ohm is 47.6 watts. Okay, now see let's see how many power in the 390 ohm. Okay, the power of 390 ohm is 25.6 watts. Okay, let's see for the 400. Let's see the power in the 470 ohm. So the power of 470 ohm is 21.3 watts. Okay, let's see the power in the 860 ohm. Okay, so the power in the 860 ohm is 11.6 watt. Okay, for the 5 and 7, these load are in the series. So what should we do? We just add one more resistor. Okay, we just add one more resistor into the circuit. Resistor. So the resistor is, so we choose the generate resistor symbol and put in the circuit, rotate and series to the R1. So R1 and R2 are in the series configuration. Okay, let's set the resistor R1 to 210 ohm, and the second resistor 470. Okay, let's see the power in the circuit. So the power in the circuit is, so the power in R1 and R2 is 14.7 ohm. 14.7 watt. Okay, so let's see when the R2 change to 860. So I change the 860. Okay, simulate it. So the reading of the power in the R1 and R2 is 9.34 watts. Okay. Okay. Okay, now for the 7 and 8, the load are in the parallel configuration. So what should we do is change the okay. So remember when to change the value or the configuration of the component in the circuit, we must stop the simulation. So we change the position of R2 to the series. The parallel configuration. Okay, delete the wire. Okay, so that one. Now we complete the circuit. Okay, you see the R1 and R2 are in the parallel configuration. Now let's test the power in the resistive load. Okay, change the R2 into 470 ohm. So R1 is already in 210 ohm. So I don't change it. So simulate. So the reading power in this total R1 and R2 is 68.9 watts. Okay, let's see what the value of the power when the R2 changed to 860 ohm. Okay, so the power of R1 and R2 is 59.2 watts. Okay, that's all for the measurement of the power in the activity 1.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Daniel bin Zakaria. Today I want to present the simulation in experiment 2 for activity 2. In this activity, there are 4 components that are included, which is AC supply, VAR meter, resistor and inductor as a load. For AC supply, the value is fixed, which is 141.4 volt, and for the frequency is 50 Hz. And for the VAR meter, they were divided into 2 configuration, which is current junction and the voltage junction. For the current junction, we need to connect it in series with the load. And for the voltage junction, we need to connect it in parallel with the load. The purpose of this experiment is to measure reactive power Q by changing the value of resistor and inductor depends on the value given in the lab sheet. For the first reading, we need to set the value for resistor to 210 ohms and for the inductor at 0.4 Henry. And the first reading we get 21 VAR. For the second reading, we need to change the value of inductor to 0.8. And we will get 23.5 VAR. For the third reading, we need to change the value of inductor to 1 Henry. And we will get 22 VAR. For the fourth reading, we need to change the value of resistor to 860 ohms, and for the inductor 0.4 Henry. And we'll get the reading 1.66 VAR. Okay, for the fifth reading, we need to change the value of inductor to 0.8. And we'll get the reading 3.13 VAR. For the sixth reading and last one, we need to change the inductor value to 1 Henry. and you will get the value 3.75 VAR. Okay, that's all for the simulation in activity 2, and thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adi bin Kamaruddin, and today I'm going to show the simulation for experiment 2 activity 3. So for this activity we have four device. The first one is AC source, the second one is wattmeter, the third one is the resistor, and the last one is capacitor. So for the AC source, I set the voltage peak 141.42 volts and frequency of 50 hertz. Then connected with the resistor and capacitor in series. For the wattmeter, we have two junction here. The first one connected in series and the second one connected in parallel. Uh, I reverse the polarity so we can gain the reactive power in positive value. So the objective for this activity is to obtain the reactive power for certain load. So we have six value of load here to simulate, and let's start our simulation. So this is the first load using resistor 210 ohms and 2 microfarad. So the reactive power that we obtain is 6.18 VAR. For the second load, we change the capacitor to 4 microfarad. So the reactive power for this load is 11.7 VAR. Next, we change again the capacitor, this time 8 microfarad. So the reactive power that we gain from this simulation is 19.6 VAR. So for now, we change the value of the resistor to 860 ohm. Then we do the same thing, uh, change it to 2 microfarad. So the reactive value that we gain, the reactive power that we obtain from this simulation is 4.86 VAR. Then change it back to 4 microfarad. We get the reactive power of this load is 5.79 VAR. Then for the last load, change to 8 microfarad. Then we simulate. We will get the reactive power 4.42 VAR. So that's it. That's for the simulation for activity 3. Um, Thank you.